How you doing? I'm Mr. Rose, and today we're going to go through a couple of just conceptual examples about capacitance. I've chosen three from our textbook. Again, our textbook is Young and Freeman University Physics. It's the 13th edition, and I've also put them up on this lecture. So what I would recommend, give a pause, maybe write this question down. Obviously, always try and think about it and solve it, like I say, before I go through and doing it. But we're going to get started here now right away. I also printed out my own little copy so I can come back and refer to this as I go. So very different. I'm going to just, write down and jot down some stuff as I go on here to try and answer these questions. So for this first question, which was 24.2, essentially we're asking about capacitors and why does it make sense that the capacitance is proportional to the surface area of two plates. So let's review a couple of things. I know by definition, really, a capacitor, right, or capacitance, I should say, is the ability to move charge. Right? So again, if I have parallel plate capacitors, I'm moving charge from one plate to the other plate because of a potential difference. And we're really asking about area. So the ability to move charge, I have real no area in that, but we do know some capacitor equations. Two of them, the ability to move charge, capacitance, charge divided by a potential difference, right? Q divided by V. And then I also can say that my capacitance is equal to the area of my parallel plates times the charge, right, A times Q, and then divided by that separation distance. We're right now just assuming some parallel plate capacitor. So now I see this area function, and does it make sense that capacitance is proportional to the area? In other words, if area goes up, does the capacitance go up? Well, we can see mathematically that's obviously true, but does it make sense on why that's true? Well, if I have a bigger area, if we talk about like an atomic scale, right? The bigger the surface area I have on my capacitor, the easier it is to have multiple charges on my capacitance plates, correct? So it kind of does make sense that if I have a bigger area, I have a bigger capacitance. But let's really kind of explore that, right? Bigger area means I could also have more charges around. And if I have more charges, right, if I'm going to increase this capacitance, well, that would cause a decrease in my potential difference, right? Those guys are inversely proportional. And what do we know about potential difference? If we can recall, potential difference is an electric field times a distance. My head's in the way. Electric field times a distance. Well, if my potential is going down, but I keep the distance between my parallel plates or whatever my capacitor is, if I keep that separation distance the same, obviously that means my electric field goes down. Well, what's the electric field doing? The electric field is the ability to move charge. If I'm moving positive test charges in the direction of my electric field, or if I'm moving electrons in the opposite direction of my electric field, either way, the bigger electric field, the harder it would be to move. Or the smaller the electric field, because the smaller the potential, the easier it would be to store up that charge on my plate, thus increasing the capacitance of my capacitor. So yes, it does make sense that if I increase the area, I increase the capacitance. Well, the next part of this question is, does it make sense that the capacitance is inversely proportional to the distance? This should be a little bit more straightforward, right? If I have a capacitor here and I start to decrease that distance, well, what's going to happen? If I start to decrease that distance, that means more charge can be held. Why would it mean more charge can be held? This is like an in-class wait time. If we increase the distance between two capacitors, the potential is also going to, my potential is also going to decrease. If my potential decreases, what is that going to tell me? If my potential decreases, my capacitance is going to increase sharply. Again, if my potential is decreasing I have less ability to, say, push those charges around. I can store that charge up much easier on the capacitor. Hope this one made a little bit of sense to you. Hope you understood what we were talking about. And that's all I have for you. Please feel free to like, comment, and subscribe. And keep thinking about these capacitors.